Hello. All right. I really want to show off this system that I made for the AI to move. First of all, I want to show this off. So I refactored all of my movement code. So it's basically the same, but it's done in a way that lets me predict where the tank is going to be, and that does that through this simulation, this perform simulation function, which returns a custom structure that I made that basically just stores information about the simulation right here. Yeah, it's just storing how long the simulation took, how far away you are from a target, how fast you're moving at the end, and the change in your position, and whether you overshoot or not. Although this overshoot is sort of finicky, but I have a workaround for it. So in this perform simulation function, all it's doing is it's doing the exact same stuff that it would normally do when it's calculating its like new position, but it's just using this while loop to sort of loop over a for a certain amount of time, and every time it does the loop, it adds a time step to it. So you can sort of pass like time.delta time into this, and it will. It's sort of like a it's like the lower time step you go, the more accurate it's going to be. So it's kind of like a Riemann sum from like calculus or something. But this is pretty cool. So if you pass like one into the time step, every while loop execution is going to simulate 1 second. And so the lower that time step is, the more accurate it's going to be. But if you have the time step be like point like 6, I believe, it's like there's only like a 2 units of error. So even then, it's fine, but it is really really neat. I like this. But what we're doing is in the update, we are assigning this to a seer object, a seer variable. And this is just to sort of predict where we're going to be in the future. And this is our time step. This is how fast we're moving at the end, and all that cool stuff. And then it's actually just like calculating the movement here in fixed update and whatnot. But these use the same functions because I wanted to be able to reuse functions. So there's one thing to like hard code a variable, but hard coding functions is kind of bad, because this way, if I ever have a problem with like my let me see, if I ever have a problem with like my where can I find angular damping? That's a good. Yeah, if I ever have a problem with like my angularity math, this will calculate basically like a 0 to 1 number based on how like perpendicular your tank is to the direction you're moving in. It's like if you're moving forward but your tank is actually rotated 90 degrees, this will give you a 1. And so if I ever found an issue with this specifically, I could just change this, and I wouldn't have to actually like go back and change every single place that it uses this function. It's just the one area that this function actually works. And I made an overload for it just out of niceness of code. But this is awesome. And so in our AI controller, what we're doing is, the idea is we have this seek function, and if the tank isn't facing the target direction, we're going to turn. And then it will accelerate if accelerating will move you closer to the target, and you're not already like next to the target, basically. So if you're next to the target, it won't accelerate, and if you're like looking away from the target, it's not going to accelerate either. And then after that, it will also check brakes. But the thing is, it has this use brakes function. I don't want it to brake when it's far away, because then it's like not really drifting. It's just sort of moving in a straight line. And so basically, if it's detecting that it's going to overshoot, it'll start braking. But it will only start checking this once you're within the right distance. So like this check brakes function will execute before we check the seer. So like if you're this is just calculating if you're close enough to the object, if you're within this distance to start braking, then it will start checking for brakes or not. So that's just, and it works amazing. I'm gonna show it off now. So right here, if I click, so right here I have, this is the AI tank, and this is the AI controller. I have the distance to start braking set to 50, and here's the target that it's using actually right here. If I start playing and go to the scene, you can see it goes right there. So this is really, really cool. That green line that I drew is from the seer, like the simulation that I made. That green line is where it will end up if it doesn't do any inputs. So like if it stops all inputs, that's where it will end up at. And so basically the way I set up all the logic is that once you're within the range for... Once you're within 50 units of the target, it's going to start checking for breaks. And then if you, at any point, that end position is close enough to the target, it's just going to stop all input. And it will just naturally, like, drift there. And so this is like, so if I put it really far away, the tank will, like, drift into position. And it looks all cool. But if it's right next to it, and let's say it just needs to go right here, it might drift a little bit. But it for the most part, just sort of turns. And it works really, really, really well. And so let's imagine like we're doing a pathfinding system. It wants to like, let's say it's starting over here. So it's starting right here and it wants to get to the other side of the wall over here. It'll probably pathfind to like this position. And then once it gets there, it's going to pathfind to this position. And so it just sort of like looks so natural, and this is like surprisingly good. So whenever it reaches its position, realistically, it'll calculate the next position, so it won't even have time to fully stop most of the time. So if I just leave it like right here and I go back into game view, I can like push the tank around and it will always try to go back to that position. It's like drifting around and stuff. It's so cool. Well, that's all I wanted to show.